Very good afternoon. So in this exercise, we'll be going to estimate the solar radiation for a given location. So for that, you need to go to these two websites. So please note down these two websites. One is power.larc.nasa.gov. This is one website we'll be using. And then the second one is the Google Maps. So because the Google map is needed to find out the location, latitude, longitude. So therefore, we need to know this website also. Okay, google.com.my.maps, and then finally remember that we are going to download the climatology CSV file. Okay, we are going to download the climatology CSV file for the uh, for this exercise. Okay, so let's go to the quickly. We'll go to the so I directly visited the site power.larc.nasa.gov. This is a website. So this site is very useful to predict the worldwide energy resources. So basically, it uses some meteorological data sets through satellite and some information, and through which they are able to document and provide us the data. So this website is slightly dull. Actually, maybe for tomorrow it is going to be dull. But today I think it's accessible. So go to the site, and then they use this option called Power Data Access Viewer. Okay, so this is the option which we are going to use. Power Data Access Viewer. Okay, so this is the data tool, mapping tool, which we will be using to find out the solar radiation for a given location. So let me click this link. So it will lead to some another site. Okay, so it will be showing a screen something like this. You can just accept, and you need to choose here. There are three options here: for renewable energy purpose, or for sustainable building purpose, or for agriculture climatology purpose. So what for you need this data access? Okay, so let us choose SSC renewable energy one, and then the climatology. We choose this one, climatology. Okay, and then here only we need to put the latitude, longitude. Okay, so here the latitude, longitude. So this exercise I'm going to give you for your own house. Okay, like where you are staying, for this house location. I want to know the solar radiation availability. Okay, so let me go to the Google map, and I will try to get my location. Okay, if there is a strong Wi-Fi connection, the Google map will directly take it to your location, basically where you are assessing. So it will take. So let me take an map of location of airport. Okay, Sultan Ahmad Shah Conton Airport. So we take this airport as a location. So you want to know the latitude, longitude, you simply click right. Okay, click right. You can find all these options. So in this, you can see the latitude is 6.78, and longitude is 103.21. So you can copy this in the clipboard, and so I'll quickly again remember this one. It's easy to remember: 3.78 and 103.21. Okay, let me go here and key in 3.78 and 103.21. So this is the latitude and longitude. And data starting date, I think no need, it will automatically take the year. Then the output format, we have this several formats. You should know which format is needed, because many of the software needs the data in a different format. For me, I would prefer CSV. It is almost like Excel file. So I choose the CSV file for the analysis, and we got a lot of options here. You can see the parameters, uh, cloud information, moisture, temperature, wind speed, battery, for sizing and pointing of solar panels for solar thermal application, solar cooking, solar geometry, solar related parameters, solar thermal infrared parameters. I will choose the tilted solar panel. Okay, I'll choose the tilted panel, and then I give a submit button. So it will take some time for processing, and after processing, we will be able to get the CSV file, the solar radiation profile for the given location. So you can see here the typical profile of this location is something like this. The solar radiation per day, the monthly solar radiation is already showing here. It is 4.24 in the month of January, then February 5.09, 5.24, 5.42, 5.15, like this. So, and then the December is 3.55 only. So this is something, the solar radiation profile. You can find out the average also. About 12 month, you can average and get the average solar radiation for this location. Because when you go for system sizing, peak sunshine hours and the daily solar radiation value is needed, no, for when we discussed about the solar PV sizing calculation for our subject. At that time, we should know what is the sunshine availability for a given location. So when you average it, you will get this value actually. So this data can be used, and then you want to download it. I will download the CSV file. I'll open. You can save, and also let me open directly, but you have the option to save the file first. You can save the file in the desktop, and then I'll get a file something like this. So this will have so many information, but we are interested in the monthly values from January until December, then annual value. So these are the values which are very important. So let me go to these columns: horizontal, latitude minus 15, latitude, then latitude plus 15, vertical. So these are the most important data. I'll highlight this one. Let me highlight this. Okay. So these are the data which are useful. So you can closely have a look into it. Horizontal surface is nothing but the flat horizontal surface without any tilted surface. So 4.19 you are getting in the month of January. But if it is a latitude minus 15 degree, how much you are getting? 3.89. If it is exactly closer to the latitude, how much you are getting? 4.27. And if it is tilted at latitude plus 15 degree, you are getting 4.44. And if it is vertical, the 90 degree one, it is 2.46. So by going through this values, which particular inclination gives the lowest value, you can see here the last one. The last one is nothing but vertical surface. So if your solar panel is kept 90 degree or placed vertically, the solar radiation availability on that particular vertical surface will be less, because the less amount of sunlight will fall on a vertical surface. So therefore, the amount of energy which you can generate from the vertical one will be very less. If you see the annual average value, which one is having a higher annual average value? The latitude is having the higher value. The latitude is how much? 4.69. 4.69 is the solar radiation availability for the tilted surface corresponding to the latitude actually. So exactly if you are placing to the latitude angle, you will get 4.69, the average, because normally we choose the average value. You need to see the yearly average. The yearly average is considered as the best one. In certain months, latitude minus 15 degree may give the best results. In certain months, latitude plus 15 degree will give a best results. But we should consider the overall figure, of average, yearly average. So this one is the annual average. It is around 4.69 kilowatt hour per meter square per day. For which location? For the location of tilted surface corresponding to the latitude angle. So this data you should copy, and copy this data in a separately in a Excel file, and then try to plot a graph among all these values. Okay, consider all these values and then plot the values for your location. The same analysis, kindly repeat this analysis for different locations, as we discussed for a ASEAN location when we started for a PV system, PV watts, we were doing some exercise in the beginning. So that time what we did, we choose one location, whatever location you have chosen, you use that also. At the same time, also do the analysis for your home location also, your house, wherever you are staying for that location, what is the solar radiation available, and then plot the solar radiation profile for a given location. So this is a small laboratory exercise report which you can make. So this specific purpose of this experiment is to is to find out the solar radiation available at different location at different latitudes, plus 15 degree, minus 15 degree, and then exactly latitude, exactly at horizontal surface, and exactly at the vertical surface. And then if you go for a tracking, actually, if you go for a tracking mechanism, then we get a better sunlight availability. Let's go into that also. If you see the latitude one, how much you are getting? 4.69. But if you could track the surface, if you can do the tracking one, then you can see this one is around 6.43. If you can track the sun, both single axis and dual axis tracking. So you can see here, EF tracker, there's EF maximum tracker. You can see the terminologies here. They are given all the definitions of here actually.
Sorry, doctor. There's
Yes.
someone want to join the class.
Okay. So you can see here, there are important terms which are given here. One is solar radiation for equator, maximum solar radiation, insolation index, all these things. So we are interested in the four values, which is horizontal solar radiation on a latitude surface, and horizontal solar radiation of the minus 15 degree, plus 15 degree. And then you can see here, solar irradiance tracking the sun. Okay, solar irradiation tracking the sun. Then maximum optimal angle, maximum solar radiation with the surface orientation, which is this one. And then diffuse solar radiation. So maybe we can choose the solar irradiance tracking the sun, which will be EF tracker. Okay, EF tracker. EF tracker we can choose. So these are the data which you can get for a given location. Okay, so this is the exercise which I would like to give you. I hope you followed this exercise. Okay, this is to determine the solar radiation availability for a given location. So this exercise, kindly do it for two different one. Okay, two different location. So if you want those who have joined late, I will repeat it once again. So first is you need to go to the site called power.lrc.nasa.gov. Okay, and then go to the data access viewer. Okay. So here there is a user key in information. You can choose the SSE renewable energy. and use climatology. Then you need to key in the latitude, longitude. To find out the latitude, longitude for a given location, you need to go to your Google Maps. Okay, go to Google Maps and choose your location. Choose your location. I am choosing a location. Let me choose Taman, a place where I am residing. Okay, so let me choose this multi-purpose Taman Hall and then somewhere here. Okay, so this is my location, and then let's see. So click the latitude, longitude is already shown. So you can copy this location, latitude, or 3.77, 103.23. Okay, 3.77, and the longitude is 103.23. 103.23. And then this one data, I think default it will take. I'm choosing the CSV file. It's Excel format. If you want the other format also you can choose, but it depends on what is the file format you need for analysis. Then among this option, I'm choosing the tilted solar panel. Okay, I'm choosing the tilted solar panel. We can also, of course, do for other cases. It will have slightly different information. I'll choose a tilted solar panel and then I give submit. So automatically in the map, you can see the location is being selected here. So then you will get a graph, a plot. So this plot I want. Okay, copy this plot. You can save this plot. Or you can download also. There is a different options you can see here, zoom in, save and edit, all these options. You can do it. And I will download this file actually. I will download the CSV file. I think multiple times I clicked, so so this is the data for this location. You can see the latitude 3.77, longitude 103.23. Out of this one, we are going to choose 4 important data, which is solar radiation on a horizontal surface, solar radiation on a latitude minus 15 degree, latitude plus 15 degree, and then the vertical surface. So this one we are going to choose from the sheet, and I'm going to highlight this information. Going to highlight. Okay, so we need to analyze these data actually. We need to analyze this data and plot this data in an Excel sheet and then see which particular value is higher for this given location. So going by this data, you can see solar radiation corresponding to the latitude is 4.69, which is the annual average value, and corresponding to latitude minus 15 degrees coming closer, which is 4.63, and latitude plus 15 degrees also coming closer but slightly lower than the latitude one, and the exactly vertical surface is the lowest one, and exactly horizontal surface comes next to it. So this is the how we can estimate the solar radiation for a given surface, whether the surface is horizontal, surface is tilted, surface is latitude, the surface is tilted at minus 15 degree corresponding to latitude, or the surface is tilted latitude plus 15 degree. And why we do this analysis? Because the solar radiation availability is one of the very important factor for assessing the solar plant performance. You want to design a solar PV plant for your home, first you should know what is the solar radiation availability on the inclined surface. So you got an idea now that if solar panel is placed exactly closer to the latitude, we get a better collection. And the next one, maybe you can keep on doing this exercise, latitude slightly higher, no, slightly higher, slightly lower also, like plus 10 degree. Then again, minus 10 degree also you can do this analysis by doing a interpolation, extrapolation and all, and then you can get the closer value also. Because if you know these two values, you can try to find the latitude 10 degree also, latitude minus 10 degree and latitude plus 10 degree also. So this exercise you can do and plot it for a given location. Okay, so this is a short experiment for all of you. Okay, so let me stop this screen.